Welcome to Lewis Diagrams Made Easy with Ket's book. Today we're going to learn how to draw Lewis diagrams for atoms and simple molecules. But before we begin, let's start with a question. How many valence electrons does chlorine have? In order to answer that question, we need to look at the periodic table. Remember that within any given column, all the elements have the same number of valence electrons. To get that number, all we need to do is count the columns starting from the left. Skip the transition metals and remember that the only exception to this is helium, which has only 2 valence electrons, not 8. Now, find chlorine in the periodic table. Remember that its symbol is Cl. See it in the 7th column? That tells us that it has 7 valence electrons. Knowing the number of valence electrons an element has is critical, and in Lewis diagrams we use dots to represent valence electrons. So, the Lewis diagram of chlorine is the symbol Cl with 7 dots around it. When you draw the dots, don't just put them anywhere. Instead, imagine a square around the element symbol. The dot should be neatly drawn on the 4 sides of the square with no more than 2 dots on any side. Practice drawing Lewis diagrams of a few elements just to make sure you've got it. This is the Lewis diagram of hydrogen, which has only 1 valence electron. This is carbon, which has 4 valence electrons. And this is oxygen, which has 6 valence electrons. Where you put the dots, it doesn't really matter as long as you neatly draw them along the sides of an imaginary square and never put more than 2 dots on one side. Lewis diagrams are often used to represent covalent bonding in molecules and ions. In covalent bonding, atoms share valence electrons in order to get a full octet, or duet. That is, every non-metal element wants 8 valence electrons, except for hydrogen, which only wants 2 valence electrons. The simplest molecule possible is that of hydrogen, H2. A hydrogen atom has 1 valence electron, but it wants to have 2. So in order to satisfy its desire for another electron, 2 hydrogen atoms will share their electrons with each other. And the crazy thing is that in the wonderful world of atoms, the shared electrons are counted as owned by both atoms. That means that both hydrogen atoms are happy because they both satisfy the octet rule. Now, we normally draw hydrogen and other molecules like this with lines to represent shared electrons and dots only for non-bonding electrons. These two diagrams of a hydrogen molecule are equivalent because one line, which is a single bond, represents 2 shared electrons. In the same way, 2 lines between atoms would be a double bond and would be the sharing of 4 electrons. An example of a molecule with a double bond is oxygen, which looks like this. Notice that in this Lewis diagram, both oxygen atoms have 8 valence electrons, 4 from the double bond and 4 from the lone pairs of electrons. By the way, 2 dots together are called a lone pair of electrons. Some molecules contain triple bonds, which we write using 3 lines that represent the sharing of 6 electrons. An example of a molecule with a triple bond is nitrogen, which looks like this. Once again, notice that both nitrogen atoms have 8 valence electrons. 6 from the triple bond, and 2 from the lone pair of electrons. Okay, how do you actually draw the Lewis diagram of a molecule? Let's start with water, H2O. There are 5 important steps that you need to follow when drawing the Lewis diagram of a molecule. First, count all of the valence electrons in the molecule. For water, each hydrogen has 1 electron, and we multiply that by 2 because there are 2 hydrogens in the molecule. The oxygen has 6 valence electrons. Add those all up, and we have a total of 8 valence electrons for the water molecule. Step 2. Determine the central atom. The central atom is the one that all the other atoms will be bonded to. It is usually the element that there is only one of. In the case of H2O, because there are 2 hydrogens and only 1 oxygen, we choose oxygen as the central atom and write it in the middle. Step 3. Draw single bonds to the central atom. Step 4. Put all of the remaining valence electrons on atoms as lone pairs. For H2O, we start with 8 valence electrons. We have used 4 electrons for the 2 single bonds, so that leaves 4 more electrons left over. We put all 4 of these remaining electrons on oxygen instead of hydrogen because hydrogen is already happy with 2 valence electrons. Remember, never give hydrogen more than 2 valence electrons. Everyone else wants 8 valence electrons, but hydrogen only wants 2. Step 5. Turn lone pairs into double or triple bonds to give every atom an octet or duet for hydrogen. Pause the video and see if all the atoms in our H2O are happy. Because each hydrogen has 2 electrons and the oxygen has 8 electrons, everyone is happy, and there is no need for double or triple bonds, which means that our Lewis diagram of water is now complete. All right, let's try one more example just to make sure that we've got this. Draw the Lewis diagram of sulfur trioxide. Once again, the first step is to count all the valence electrons. There is 1 sulfur with 6 valence electrons, and there are 3 oxygens with 6 valence electrons each. 6 times 3 gives us 18 valence electrons for the 3 oxygens. The total would be 6 plus 18, which equals 24 valence electrons. Step 2. Determine the central atom. This time, sulfur is the central atom because there is only 1 sulfur in the molecule. We write sulfur in the middle with the 3 oxygen atoms all around it. Step 3. Draw single bonds to the central atom. Step 4. We started with 24 valence electrons, and we have used 6 electrons to make the 3 single bonds. This means that we have 24 minus 6, or 18 valence electrons remaining. We now put those remaining 18 valence electrons on atoms as lone pairs. Count by 2s when adding them. 2, 4, 6, 8, 10, 12, 14, 16, and 18 valence electrons. That's it. We've now used up all of our valence electrons. Step 5. First pause the video and check to see if any atom does not have an octet or duet. That's right, the sulfur is unhappy because it only has 6 valence electrons. So what can we do to make it happy? We cannot just give it more electrons since we don't have any more. Instead, one of the oxygen atoms can take one of its lone pairs and share those 2 electrons with sulfur in another bond. The double bond between oxygen and sulfur now makes every atom happy with 8 valence electrons. Be sure to follow these steps when drawing Lewis diagrams. Thanks for watching. Please comment, vote, subscribe, or check me out at ketsbook.com.